afternoon, this is Schweitzer, and run through a little video here on how do I know when a chemical reaction is taking place. So this particular video is going to highlight two different types of process. One we might refer to as a chemical reaction, and the other one we'll refer to maybe as more of a physical reaction. Okay, so chemical versus physical process. Now then in class, this is going to be something where there's going to be quite a number of chemical demonstrations. It's always more interesting to see it in person than it is to see it by a video here, but we'll do our best with just some pictures. Alright, so first things first, our first chemical reaction here is going to be, okay, what do we see here? Okay, so we have a chemical process taking place here. What do you see? Well, first thing we're going to sketch out here, we're going to do three different demonstrations. I have three different chemicals. One is potassium iodide and PbNO3, like this. And we have potassium iodide and Na2CO3, and then we're going to do a third one involving potassium lead nitrate. So three different chemicals, we're going to mix them together, and then the sodium carbonate, like that. Okay. Turns out this one here ends up turning yellow, kind of like this guy right there, and this one ends up staying clear. Nothing happens. And the other one is going to turn white, which is this picture right here. So a couple things we might note here. One is that we have you let it settle for a while, you take a real close look, you'll see a solid forming. And that is a term called a precipitate, which is a new solid being formed. Okay, so a chemical reaction is one where, just to highlight this, is where a new substance is formed. And that might seem easier than it might look, but it's on the atom level, at the atomic level, or I should say maybe at the molecular level. There's a rearrangement of molecules forming, or atoms in molecules. So it's not as easy to say whether there's a new substance or not, because you have the same atoms. So sometimes it can be a bit of a fuzzy situation, and it's just a matter of classifying whether it is or is not a new substance. So a chemical reaction is one where there is a new substance being formed. And at some point, like with a solid happening here, precipitate, we can see, with our eye, okay, we can see that this thing has a new solid. Something we could look for. Alright, next one. Okay, drop a piece of zinc into some hydrochloric acid, and says, okay, what happens if a new substance is made? Are we guaranteed to know it's there? Again, we look here, what do we see here? What do we see? We see lots of bubbles. Okay, and this is an indication that we have a new substance being formed. And this new substance happens to be a gas. And the gas is in a liquid, so we can see it bubbling through the liquid. There could be, as it states here, could there be a situation where a new substance is being formed and we don't know it? What might be a situation where we wouldn't know a new substance being formed? Think about that for a moment. Pause the video. Take a look. Alright. The answer might be that this new substance could be the same as the old. It'll just look the same. Maybe it's clear and colorless. I would note that at this point, we're bubbling these things through, but if for some reason we had a chemical reaction that was just sitting in a solid, it was giving off a gas, we wouldn't know it. If it's a clear, colorless gas, we would not know the gas is coming off. It would weigh less, though. So we put it on a scale, it would actually weigh less after the stuff left. How do you know a new substance is being made? Again, this is one where, we have to be able to see it. Literally that substance has, it's my eyeball. So we're looking for something that we can see. Now again, these are indicators that we have seen so far. So we've seen two of them. One is a new solid, which is precipitate. And the other one is going to be gas evolution. This is one of 4 different indicators. Now, what's an indicator? An indicator is something that indicates an idea, like it's leaning one way. It's not guaranteed. Okay? It just looks like, the Packers are up by 14 points, 2 minutes left. It's a good indication that we're going to win the game. But, again, is it possible that we lose? Yes. Okay. All right, so 2 indicators. Start looking for this. They're all based on the same idea. New substance that looks different so that we can see it. Not guaranteed. All right, so drop same copper here into a different solution. Now, you notice that the penny, as I mentioned before, this kind of really cool looking bit on this penny. The outside's copper, but the inside is zinc. Right? So in this case, we have copper reacting with nitric acid. It forms a really gnarly looking substance. What indication do we have here? First one we have would be a color change. Again, a new substance being formed, and this new substance happens to have a new color. And therefore we can see it. You'll note there's also going to be some gases coming off of this one. Okay. Would it be possible for an indicator to be present and not be a chemical reaction? I wouldn't bet my life against it. It's possible that you could have some sort of a color change or whatever and not be a chemical reaction. For example, you take like soda, right? This is a pretty common one. And you open it and all of a sudden gases is coming out. Does that mean there's a gas evolution? No. Just the gases were trapped inside before and now they're just escaping. So, might be a little more rarer to see color changes and not have a chemical reaction, but I wouldn't bet against it. All right, another example. Sulfuric acid going into some sugar. We get this chemical reaction occur. Again, it's just a rearrangement. So remember, chemicals are not created or destroyed, just rearranged. And they're going to be rearranged into a couple different things here. All right. With that being said, what do we got here? Well, we could see some carbon, right? So maybe we got some carbon, solid carbon here. We got some gases, and you wouldn't know this unless you actually see it. But it's steam, so it's water in the gas phase. What else? We got? There's going to be some sulfur there someplace. It smells kind of bad, so maybe there's some sulfur dioxide. There's lots of stuff happening, and there's a lot of chemicals here, but most of them are just some carbon dioxide, I'm sure. But all those atoms are going to be rearranging into forming new substances. In fact, it turns yellow in there too. So these are some ideas about what we might be getting here. Okay. An analytical chemist could go through that and use some techniques to try to figure out what's actually still there or what's in the gas. Okay. So what indicators do we see? Obviously, we have gas evolution. We have color change. We have a new solid being formed here, right? So a new solid. We have a term for that called precipitate. But this steam is a new one here, and that would be energy. Okay, energy being given off. This getting hot. You would not be able to hold this with your fingers. We call that exothermic, where our system is losing energy to the surroundings. All right. So last but not least here, I think is one of our last things here. 2 balloons, and we're going to explode these balloons, and just kind of see what we got here. The first one, again, it's reacting with oxygen. And this here, so let's balance it. Pause this for a moment, balance this reaction. Okay. So 2 hydrogens, 2 oxygens, ions. Put 2 here. And then put a 2 here. So this is the rate used. So this one balloon is going to have straight hydrogen. There's going to be oxygen around the outside. There is an excess reaction amount of oxygen around the outside. So plenty of oxygen here. And what we get here, so one of these guys grabs that guy. Actually, 2 of these guys grab one water molecule, and they form 2 waters. Does that make sense? These 2 guys grab another one and form 2 waters. And another 2 grab 2 more waters. So this can get pretty mathematical. I mean, now it blew up. So gave off some energy. Alright, what do we got here? Now this one, I put the oxygen right in the balloon. So now, these two guys here grab onto this guy and form a water molecule. And these two guys grab onto those guys and form, they form two water molecules. And this guy forms two water molecules. Okay? So, with that being said, what do we got here? Here we got 4 water molecules. Here we got 6. And the balloons are the same size. So, we got 1, 2, 3, 4, 5, 6, 1, 2, 3. They're the same number of particles. It just so happens that this one happens to have some oxygen in here as well. So which balloon gave off the most energy? What do you think? Okay. Why did the first balloon feel different? Why did the second balloon feel different? Well, if you're not in class and you don't know this, well, it turns out that this guy is going to give off a lot more energy. And this balloon feels a lot more heat. You will feel the heat come off this one. Because literally there's more hydrogen. And therefore, you get more water, but you also get more energy, more physical heat. This one, because they're so close, this reaction goes much faster. Not even the right amount of energy, smaller amount of energy, but it goes faster. So, this case, it produces a much higher pressure wave, and therefore, it's much louder. And just you look at the amount of time it takes for this one to explode versus this one to explode, this is much faster, and therefore has a different effect. Either way, those are our products. So, physical reactions, and we'll do, this is typically another day, okay, but it's going to be a short little addition to this video, so I'm just going to put them both together, okay. Can you burn, boil water, paper bowl? So we're going to set up a little demonstration like this. Paper bowl on a ring stand, and we want to know, can I boil water on a paper bowl? So the answer is yes, the answer is no. This is for students to hypothesize as to why you would or why you wouldn't. Okay? Maybe take a stand on one of the other two that you might think. Alright, so next is phase changes. Again, during this time, our little experiment would be going on of this trying to boil water in a paper bowl. So heating curves. So this is an example of a physical change. So all we're doing is warming it. Going from solid to liquid to gas. There's no new substance. That's important. Okay? Same substance, just in a different phase. So phase changes are pretty common. We use this spot to introduce the idea of a heating curve. We have that looks something like this, and there are lots of variations to this depending on the substance. This is the range of solids. This is the range of liquid. And this is the range of gas. So, with that being said, we have just some terms here that you're familiar with. Solid going to a liquid versus liquid going to a solid. This is melting. Pretty common term. And this liquid going to a solid is called solidification. Now, solidification could also be freezing. Freezing, not the best term. It's more for our human everyday life term thing, but in science, solidification is better. Liquid to a gas, gas to a liquid, vaporization, and condensation. We do, however, have solid directly to a gas, which is called to sublimation, and then gas to a solid is called vapor deposition. So anytime you see one of these terms, it's a good indication that this is in fact a phase change and not really a chemical reaction. Okay. All right. Another example, physical manipulations. Okay. Again, this is something like where you would tear, cut, bend, something like that. Okay. Key idea here is that we're not creating a new substance. Okay. Or just bending or breaking these things on a larger level. Here are 10 examples, and your job here is to pause the video and indicate if it is a chemical or a physical change. Alright, come back with the answers momentarily. Okay, so cutting hair. This, again, it could be described differently. Like you could cut your finger off, that's a physical change. Then a chemical change comes after that. Okay, but they're going to call this a physical change because there's no new substance formed, and it's just a physical manipulation. Water evaporating off the sidewalk. Evaporating is a term that is just a phase change, physical. Opening a can of soda. This is, again, not really, it might be gas coming out, but there's no new substance, physical. Leaves turning from green to brown. This would be likely a chemical reaction due to color change. That's an indicator that there is a chemical reaction going on here. Cooking a hot dog over a campfire. Now again, this could be one that could likely be either. Are you simply warming it? If you're just warming it, then this is a physical. Alright? If you are actually cooking something, however, it could very well be chemical. Baking, for example. Of course, if you stir it on fire, like a marshmallow over a campfire, right? It's physical until you stir it on fire. Then it's chemical. Mixing. Clear liquid, we did this one in class actually, so it's a color change, and it is going to be because a chemical reaction. Burning the gas in your automobile on the way to school. Okay, that's definitely a combustion reaction, a chemical reaction. Lots of indicators here, whether it be energy, okay, gas evolution. Campfire, a good example of chemical for the same reasons. Sharpening a pencil. That's just simply cutting your pencil, physical. Formation of liquid on your mirror during a morning shower. This is condensation and therefore physical. 10 examples to give yourself an opportunity to try it out. Thank you very much. This ends typically our chapter on Introductory to Chemistry.